father of an HLHS kiddo. His name's Micah. He's 6 years old, and I work with the Micah Mason Foundation as their managing board member. And today I'm going to bring you a review of the HeartWorks. Grab it here. Got it. The HeartWorks quarterly update. So, if you watched our video about HeartWorks, they are an organization sprung out of the Mayo Clinic's Todd Karowanek Foundation, and their motto is "They build hearts." Their programs are basically based around. Yeah, see if I can use that word as many times as I can. But their program is to take research that's been done either in their lab or maybe elsewhere, bring that research into clinical trials, animal trials, followed by human trials, and then out along the FDA track to get them out to the public and then into kids. So, and that's ultimately directly aligned with the desires of the Micah Mason Foundation. So we're big fans, big supporters, and so we go to the quarterly meetings. We've been on the lab tours. We participated in their Cures in the Works fundraiser, and so I want to let you know a little bit about their quarterly update. Started the quarterly update, and a link for this video is going to be in the bottom below. Well, it'll be a link to their site, and I'll see if I can get a link to the video as well. It's going to be in the comment section below. So they started with a CHD kid story, so it's a child like Micah, maybe like your child, and then the story with that child and their parents and their connection with HeartWorks and what they hope to do in the future. And the part of the point of these is that some of the children that are showcased in their stories are children who have been through some of the clinical trials, like the umbilical blood cord trials, are far enough along that they've had human patients who have had the umbilical blood cord were taken and then had the resulting product from that put back into the children during their Glenn surgery. And they're looking at also expanding that into the Fontan surgery. Obviously, there's the kids that are part of centers that are involved with a consortium where umbilical cord blood was taken. So if you have a child who's at a consortium, this is something you could look into because it's still an ongoing process. It's still in trial. So then they did what's the story, and if you want to watch that story, I'll let you watch it on the web, but I'm not going to repeat the story. So the next thing is a lab update. What they did was they showed, I think the most famous version of this is there's a TV personality on a news show about 10 years ago who did this, maybe not 10 years ago, maybe more like 5, either way, who had a skin biopsy. Basically, they took a little bit of his skin, and they took that and they grew heart tissue in a lab from that biopsy, and they showed us this biopsy not from that guy but from Allie, who works with HeartWorks, and so it was Allie's skin tissue that they did this with, which was really cool. She's a really cool person. So in weeks, what they can do is they can grow cells on a plate. They take that skin biopsy and they put it on a plate, and they grow cells from those skin cells, and then they begin to reprogram those cells to be stem cells, so similar to embryonic stem cells. And then they do what's called a cardiac differentiation protocol, which is stem cells could be any type of cell right there. That's why they're called stem cells, is because they have a potential to become anything. And so they perform this protocol on it that results in the stem cells becoming heart tissue or cardiac cells. After about 4 to 5 months, they scale up and they turn them into heart and muscle cells, and you get enough cells to equal cardiac cell load in a baby. So that's kind of where they're at. Like, that's what they can do in their lab. If you go on a lab tour, that's what you'll see is the cells in the jars and the test tubes or whatever, and they're putting together enough cardiac cells to equal effectively the tissue load that you maybe have in a baby. Or some percentage of that. So the path forward for this particular project, what they want to do is take these cells and inject them into the hearts of HLH kiddos in the hope that if you take an HLH kiddo's skin biopsy and then a year later you have, or a year or so, 18 to so months later, you have all these heart cells and you can put them, they're healthy, they're active, you put them back into the heart environment, and the hope is they will do something good. I'm not a medical professional, so there's probably a lot of terminology in there that I'm not missing, but that is the research project. You put these cardiac cells that are the child's, so it's not somebody else's cells, it's not a transplant situation. The child cells, you put them back in, and they're going to bolster the heart. They're going to bolster the heart cells that are there. They're going to help the heart function, and they're hopefully going to do good things for the heart. So they are right now coming out of animal trials. So they've done animal trials with this. And so the way this works, the overarching thing is you have animal trials is the first piece of it. So you have to prove it's not going to hurt the animals, and that it might hopefully get some data that it shows it might actually be good for the test subjects, although there's no guarantee there's any sort of transfer between mice and humans or pigs and humans or whatever. Although I think pigs is one of the primary ones that gets used for animal testing just because of similarities in a lot of cardiac stuff. So if you have animal testing, then what you're done with that, you go to phase 1 clinical trials. So it's a small number of human patients. You have both, the human patients and then control patients, who are patients that don't receive the treatment, who don't receive the treatment, and then they're compared with each other, and that's how you have you get a control population, a test population. You compare the test population to the control population. Phase 1, you're showing, okay, this didn't hurt anybody, and this helped. This is what you're doing. You're moving from phase 1 to phase 2. Phase 2 basically is a bigger. So phase 1 is sort of like, okay, did this help? Did it help as much as we hope it helps? And did it hurt anybody, and in what way? You move on to phase 2. You get a bigger pool of patients, a bigger control group, and you're asking, okay, so you have a larger pool to work with. So scientifically, it's always a good thing, and you're working on efficacy at that point. You're looking at, okay, what's the best way to do this? Where's the best way to put these? What's the best way to do? So there's a lot more variables you can put into the clinical trial to change things to figure out the best way to do this thing that we're trying to do. And then in phase 3, it's a much larger pool, and you're mostly monitoring for adverse reactions at this point. By the end of phase 2, you've worked out the kind of best efficacy, the best way to do this thing, and the best way it's going to help people. And in 3, you're widening your patient pool to look for, adverse reactions both on the wide scale and on the acute scale, because you get through phase 2 trial not seeing adverse reaction because your patient pool is so small that it doesn't include people who would adversely react. And so that's part of the phase 3. Where they're at right now with this, the growing the cardiac cells and then injecting them back into the patient, is they're working on phase 2. They're working on phase 1. So they've completed animal testing. Now they're working on phase 1. They're working on submitting the IND application, which is the investigative new drug application. So they're putting that into the FDA in June. This is a first of its kind, so first in the world of doing this kind of thing where you're using the patient's own cells to build stem cells, to build some cell, cardiac, liver, whatever. I mean, you could do this for other stuff too. It could be potentially helpful. So if it proves out to be good for the heart cells, it could prove out to be good for patients who are going through liver failure or through kidney failure or through later patients who are going through heart failure. Like, this could be good for adults later on. So this is first in the world. So there's likely going to be a lot of back and forth between HeartWorks and the FDA on how this is supposed to work, but the investigative new drug application, they're shooting for June, so that's not too far away. It's only a couple months. So like I said, there's going to be FDA review and feedback. Then they move on from that to the institutional review board, and they've got to get approval. So basically, after the application's in, then the review board reviews it and says, okay, they either give a final yes or a final no. They say, yeah, go forward, don't. And once they get that approval, they'll go forward at the consortium site. So like I said if you look at the HeartWorks video that we talk about their consortium. So it's a number of hospital sites that are tied in with the Todd and Karen Wanak Foundation at the Mayo Clinic and with HeartWorks now to support their research efforts. Basically to provide the pool for the phase 1, phase 2, phase 3 trials. And then they begin recruitment and they move into treating their first patient. So that's where they are right now, submitting that application. They don't know how long it's going to take to get to the approval point and then to move into patient trials. But once patient trials are open, I suspect they're going to have a lot of people extremely interested in this. Even if your child is not cared for at a consortium site, there's a chance you could get involved in the trial by connecting with HeartWorks and or the Mayo Clinic, or connecting with one of those other consortium sites. There's also the chance that you could take part as a control. Like if you're a patient or a parent of a patient, you can have your child as the control, part of the control group, which means that you don't have to do anything. Like there's no testing going on your kid. You're just giving them data so that they can compare to children who are getting the treatment. So you can be involved, and that's always what we're about here. So get involved. The next piece was Pathway to a Cure. So they showcased there are 4 ongoing projects they've got, and I wrote them all down on this handy dandy chart here. So path forward, you've got the umbilical cord blood, which we talked about. You've got the bone marrow project, which I actually don't really know much about this bone marrow project, like at all. So I don't know. Then you've got what I've been talking about, the bioengineered cardiac lineage cells, and then finally the bioengineered pump. So what the bioengineered pump is, so the cardiac lineage, which just, you take the kiddo cells and you put them back in the kiddo's heart to see if it'll help the heart function. Bioengineered pump is to take those cells, put them on some sort of lattice or scaffolding, and then make a tubular heart. And kind of just a pumping mechanism that would, and this is obviously way bigger than it would be, but you would put it inside of the, it's not the heart, it's not the artery. That's what it's called. You'd put it inside the artery, and it would pump, and that would provide pressure help. I mean, because I don't want to get too technical. I'm an engineer and I deal with pumps. So I work at a power plant. We move a lot of water at a power plant, and I deal with a lot of different kinds of pumps. So this would be a positive displacement pump where it's pushing the fluid along by constriction, forces it out. But that's exactly how your heart works. Your heart is a positive displacement pump. It's not a centrifugal pump, and it's a lot different from the, I can't remember what their acronym is for it, but the devices that get used. So the cardiac replacement devices. And we just hit a milestone. I want to say there's a guy now living who's 18 months, longest to be living with a cardiac replacement device. He doesn't have a heart. He just has these pumps that are doing the work for him. He has a bag that the tubes come out of and go back, and then, well, the tubes don't come out and come back. The wires do, because the bag is the battery for this thing. But they're centrifugal pumps, so they're not positive displacement like the heart is. But that would be the idea behind the bioengineered pump, is that it's a biological pump. Like the heart, it's positive displacement. It's going to be inside the tube, the arteries, and help. Because that's the biggest problem with the Fontan circulation is the blood pressure. Like, you don't have enough pumping motion to keep the pressures where they need to be in order to get enough blood flow through everything in the body. And that's why you have the problems you do with failing Fontan. You've got the heart failure because it's running out of energy because it's one pump trying to do what 2 pumps are supposed to be doing. Got the plastic bronchitis because the stuff isn't being moved out of the lungs fast or quickly enough, and so it builds up there. You've got the liver problems because not enough blood flow is going through the liver. The There's another one that deals with basically. There's another one that's much more technical that I can do, and I'll have some information on that down below. But all of it goes back to the fact that the blood flow is not where it should be, and so that's what the engineered pump. So if you look at the chart, where they're at with a lot of this stuff, you can see, and they have dollar figures next to. So for this, they talked a lot about the bioengineered cardiac lineage stuff, which is what we talked about mostly before this. They're about $2 million, $6 million for phase one. So that's a lot of money to pull off phase one. But you heard they're doing in June, right? So this is like total cost for phase one, which kind of leads us into the next piece of this, which was the update, which was fundraising. Basically, they've been killing it, which is good. They had their February event, which was a cure is in the works. Unfortunately, we were not able to participate due to work, or I was not able to participate due to work. Our family wasn't. But the Micah Mason Foundation was a part of that. We were a small part because they raised about somewhere between $700,000 and $800,000. We, provided about 10, so it was good for us. But every little bit helps, as I always say. But that was a pretty good chunk of change. They're attempting to raise $2 million this year. That's their goal. They raised about $800,000 last year. So it does look like they are on target to make the amount of money they need to fund the research by the time they need the money, if that makes sense. Because like I said, there's going to be a lot of back and forth with the FDA. And then once clinical trials start, the hope is we'll be able to get the consortium centers on board with paying for some of that. So the $6 million isn't necessarily going to be just HeartWorks. But that being said, if you want to support HeartWorks, highly recommend it. Or if you'd like to support us, we support HeartWorks. So, yeah. Either way, it's all good. They also brought up their next event, which is a virtual lab tour. They're going to do that on Wednesday, May 18th. It's over Zoom. They're really cool. Dr. Nelson basically takes you through the lab there in Wisconsin, Mayo Clinic, Wisconsin, I want to say, or Minnesota. Somewhere out there. I'm in Texas. That's like really far away. But either way, so the virtual lab tour, May 18th, and they're really cool. I highly recommend going to them. You get to ask questions. It's a one-on-one with the guy who is kind of the powerhouse behind HeartWorks, Dr. Nelson. He's a really cool guy, and he's really knowledgeable. So if you've got questions about anything related to HLHS, because he's been more or less crusading for a cure for a long time. And he's been at this a long time. So we're very happy to support HeartWorks, and their quarterly update was very positive. So they're moving forward. We're looking forward to phase one trials, and to see the results of that. So thank you for listening to our review here. We appreciate your support. If you'd like to support the Micah Mason Foundation and our mission to raise funds for research for a final cure for HLHS kiddos and eventually all congenital heart defects, and to get the word out. So we want more parents involved, and we want to keep y'all knowledgeable. Even if you don't get involved, we'd rather you know about what's going on in the research community and the hope that we have. So if you ever get discouraged, there's a lot of hope. There's a lot of hope out there. There's a lot of different groups. HeartWorks is one of them, but there are other groups doing research. There's a lot of good work going on, and so we're very happy about that. So if you'd like to support us, there's going to be a link in the comments to our website, and you can donate there, as well as a link to the HeartWorks website and their video and quarterly review, and then keep make sure I get the May 18th on the calendar if you want to go see the lab virtually. So thanks. I am Pat with the Micah Mason Foundation, and we are all in this together.